Today we started with linear program basics. These are topics that we're going to cover that will be on the final. We just didn't have time to put them on the test. Linear programming is used in business and all kind of commercial and financial companies use this because it helps them find the max and the mins of different activities and things that we're doing, specifically with cost, time, jobs, all that stuff that they're going to do. We are going to use a feasible region by graphing a system of inequalities. And we're going to find a max or a min to help us find the answer to whatever they're asking. And we use the vertices, or the vertex, of the region to find it. We use it in an equation, and you'll see why. This page right here is due Tuesday, December 4th. It's 4 problems. We'll have time each class to do some more, but it's due December 4th. Alright, let's go to this page. Now, we're starting with something that you know how to do, basically graphing. You know that for linear, it's y mx plus b. Normally we put it equal here, but we've got greater than symbol, less than symbol, greater than or equal to, and less than or equal to, and you'll put that there in place of the equal. But the mx plus b, the slope and the y-intercept is still the same. So on this first one, what's wrong is the left side has a 3x. We need to move it to the other side. So 2y is less than negative 3x plus 8. Then we have a 2 here, so we have to divide everything by 2. So y is less than negative 3 halves x plus 4. We're going to graph that here on the graph. We're going to start with a 4. And we're going to go down 1, 2, 3 over 2. Down 1, 2, 3 over 2. Down 1, 2, 3 over 2. And one more time. We can also go up 1, 2, 3 over 2. And this line, because it's just less than, is going to be dashed. And because it's less than, we're going to shade below. But we're not shading yet. We'll wait to shade till we're done. Alright, let's look at the next equation. The x needs to be moved to the other side. So you have negative 2y less than or equal to negative x plus 8. And we're going to divide by negative 2. When you do that, this flips. So y is greater than or equal to 1 half x, and then 8 divided by negative 2 is a minus 4. We'll start graphing that. 1, 2, 3, 4. And then we're going up 1 over 2. Or down 1 over 2. And this will be a solid line this time. We'll draw all the way across. Solid. Oh, and we're shading, because it's greater, we're shading above. Now the reason I do the direction arrows is it tells you that when they overlap, that's when our solution area is. So this is our solution area. Now there's one very similar over here on the right, but it is bounded, all 3 sides. Let's start with this horizontal line. The horizontal line is at 3, and it's just going to be a symbol where it shades below, so it's less than, but with no inequality. That's our first equation. The second one, this run right here, hits at negative 1. That's our intercept. So we'll start with the negative 1, and then we go up 2 over 1, so it's a 2x. It's above, so it's greater than, and it's solid, greater than or equal to. Our last one is this one over here that intersects at 1, 2, 3, 4, 5, negative 5. And our slope here, the rise is a negative 2, the run is 1, so negative 2x. Again, it's above, greater than. And you're done. That's number 2. Alright, number 3, last one. In order for us to graph it, we need to change these two. So y is greater than or equal to negative x plus 7. And here, that's this one, here we're going to move the x over and then divide by 2. So let's start with this first one in graphing. So we start at the positive 7, and because it's down 1 over 1, all the lines for this particular problem are solid, and because it's greater than, it's shaded above. Next one, we're going to start with the positive 8, and the slope is down 1 over 2. Again, solid line. And because it's less than, arrow below. Now these two are vertical and horizontal lines. The vertical line, x is greater than or equal to 2, is the whole 2 line to the right because it's greater than. And the y is greater than or equal to 3 is a horizontal line and it's shaded above. So our little area is bounded by this line, that line, that line, and that line. They have vertices right here that will help us with our solution. So let's start up here in the corner. I have 2, 7. So that'd be 10 times 2 plus 8 times 7. So 20 plus 56 is 76. Next one is 2, 5. So 10 times 2 plus 8 times 5. So 20 plus 40 is 60. Then we move on to this point right here, 4, 3. And that gives us so 24 and 40 gives us 64. And the last one is 10, 3. So 10 times 10 plus 8 times 3 gives us 109. No, sorry, 8 times 3 is 24. I thought that was 3 times 3. My apologies. There we go. So 8 times 2 is 24. It's 124. So if we're looking for the minimum value, that's going to be the smallest one. The 60 would be the min. Alright, we'll do some more on Monday.